Hello, everyone, and welcome to today's webinar. Discover the EBENTO One-Stop-Shop, one platform, every renovation solution. My name is Raquel Castan from Metra. I'm partner of the EBENTO project, funded by the Horizon Europe program. And I'm delighted to be your moderator for this webinar session. This webinar is one of the final dissemination and exploitation activities for the EBENTO project. So during the next hour, we will present the EBENTO One-Stop-Shop platform, explain the concept behind it, and demonstrate how it supports stakeholders throughout the entire building renovation journey. So today we have with us several partners, technical partners of the EBENTO project, like Shima, David, Nicolaus, Anais, and myself, Raquel. So welcome everybody. Thank you for participating in this webinar. And we will hear from these partners who have contributed to the development of the platform and its different models. Together, they will show how EBENTO helps simplify renovation processes, facilitates collaboration among stakeholders, and also support implementation of the energy performance contract schemes. So thank you all for joining us today. And let's begin with the introduction of the EBENTO itself.
Okay, thank you, Raquel. Well, EBENTO is a European project funded by the European Commission, in which we are focused on preparing a single platform which is integrating the actors and the themes and the modules that are covering all stages in a refurbishment, of a building, of a dwelling, of a shop. So the idea behind is to bring in an easy way the improvement of energy consumption, of comfort conditions through the energy performance contract that Shima is going to explain later on, and bring together all actors and so on. We have focused on, or we have 5 objectives, as you can see in the screen. For instance, we are applying innovative technologies to the renovation market. For instance, the energy performance contract, the NILM, the smart monitoring, simulations, and so on. We have implemented new performance-based business model. For instance, the simulation, the monitoring, the smart monitoring of energy and comfort. Another objective is that the condition-based maintenance replace the maintenance contract, the traditional, I mean, with this energy performance contract that are very, very innovative. As well, we try to use the performance warranty to valorizing energy and comfort improvement after a renovation process, and we try to increase the traceability of the performance and the replication, because we have included a lot of modules that are registering and are tracking all the stages in a refurbishment project with these features. This is we have different partners with different profiles. For instance, we have the technology providers that are all we today. ETRA, CEMOSA, and Hypertech. We have experts on economics and social science like ICP, Johanneum Research, the University of Ljubljana, and its Institute for Innovation and Development. And we have 4 pilots that are the contact with the end users: Valencia Sostenible, Medlen, Almighty Lineos, Carbon Cube, and Taltech. They are from different countries, so we can test EBENTO in different weathers and situations regarding social, weather, and different topics. the stakeholders for EBENTO are any person or company that is interested in a refurbishment project. For instance, an Olmar citizen that needs to improve their dwelling, a builders who want to get potential customers, energy services providers, authorities, social agents, and property managers. I mean that this is a platform for everyone that needs to deal with a refurbishment process. And why? Because as we are going to comment later, we have a shared meeting point to all the stakeholders. It is it is an easy access to providers and potential customers. They can meet in an easy way. All customers, all users know in which state of the renovation they are, which action are doing in each moment, and what is the progress, and different aspects related with that. And the technical data is in understandable language, so a person with no technical knowledge can understand in which part and in which situation his or her dwelling or building is. That's all.
Thank you very much, Anais. Well, as we have just seen, building renovation involves many actors, processes, and decisions. And one of the key ideas behind Evento is making this complexity easier to manage through a one-stop-shop approach. To better understand this concept, I will now like to invite Shima from IEECP to explain the one-stop-shop concept and why it can play such as an important role in accelerating the energy renovation.
Okay. What is one-stop shop for building renovation? A one-stop shop is a single service, one entry point that guides a building owner through the entire renovation journey. And instead of managing many different experts, contractor and financiers separately, the one-stop shop takes care of everything, including technical advice, contractor, financing, quality control, and also monitoring. You can think of it like booking a package holiday. You do not call the airline, the hotel, and the tour guide separately. You go to one place and everything is arranged for you. Also, research across 63 one-stop shops in 22 European countries shows that this approach works. It helps homeowners overcome the barriers that normally stop them to conduct the renovation, the cost, the complexity, the lack of trust, and difficulty of finding reliable contractor. And the EBENTO platform is a digital one-stop shop bringing all these services together in one place. And I will now hand back to Raquel, who will show you exactly the next step.
Yes, now that we have explored the general concept of the one-stop shop, let's see how this approach has been translated into a practical solution within the Evento project. So Anais will give us more information about that.
Yes, sure. Well, as Sima has commented, the one-stop shop is a concept that integrates all things related to a process in a single application. So we have brought the concept of one-stop shop to Evento. We have different models, as you can see here in different colors, and all data is visualized and handled according to the contract stage and the contract status and the situation. So on one side we have the proper Evento one-stop shop in which you receive information about calculations, about evaluation of all the modules, but behind that we have other 4 modules. The first one is the Evento decision support system for renovation. That is a simulator in 3 dimensions where the user can evaluate different scenarios for the renovation, as my colleagues are going to explain later. Apart from that, we have the EnPC module and the Evento economic simulator that is the handler of the innovative contracts that we are considering in EBENTO. It is monitoring that the elements that has been contracted are really meeting, and it is comparing the contracted situation with the current situation. Another module is the EBENTO ECE, that is an evaluator of the physical situation in the house or in the space. For instance, the comfort, the saving of energy, some action in regards the demand response, and so on. And finally, the EBENTO IoT data platform that is related to the data ingestion of real-time monitoring.
Thank you very much, Anais. So the development of the EBENTO One-Stop-Shop has been possible thanks to the expertise and collaboration of several partners with complementary skills. We are very lucky to have them today. So before we move to the platform demonstration, I would like to briefly introduce the technical partners behind the solution and their respective roles within the project. So please, Hypertech, Semosa, EECP, and ETRA, can you please introduce yourselves and your roles within the EBENTO project?
Sure. Should I start?
Yes, please. Go.
Thank you. Great. So my name is Nicolas Stathopoulos. I represent Hypertech Sustainability Research and Technology Center, which is a non-profit research and technology organization based in Athens, Greece. Our work focuses on the development of digital solutions for more efficient and sustainable built environment. Within EBENTO, we serve as the technical manager of the project, and we're coordinating technical activities and support quality assurance. We were responsible for the design of the EBENTO architecture, which was a process that included the definition of the functional requirements of the platform, the one-stop-shop platform, as well as the definition of system components and respective data flows between the components. We also led the development of the DSS4 tool that supports building renovation planning. And I'm not going to go now into details because this is going to be presented in detail in a few moments.
My name is Shima Ibrahimi, and I represent ICP, the Institute for European Energy and Climate Policy. We are a non-profit independent research foundation based in the Netherlands, and we were established in 2015. And our work covers 5 areas, as you can see on the screen: energy efficiency policy, local action for energy and climate, consumers and community, energy efficiency financing and business, and also buildings. Across these areas, we work both as project coordinator and as a partners in EU-funded program, including LIFE and Horizon project, which bring me here today. So in EBENTO, ICP has 3 specific responsibilities. First, we are the business models and EnPC, energy performance contracting expert. We led the legal and contractual analysis and innovative performance-based business model using the business models canvas framework. Second, we are the EnPC contract integrator, and we translate the business model into energy performance contract type, which are included in the EBENTO One-Stop-Shop platform. And third, we led the social economic impact assessment and replication, and we coordinated technical and social economic impact assessment across all 4 pilots in Valencia, Athens, Tallinn, and Manchester.
Thank you very much, Shima. And now, David, please, can you introduce yourself?
Okay. Hello all, my name is David, and I represent Semosa, which is an engineering and quality control company in the construction sector, covering both transport infrastructure and building services. It was founded in 1972 and is based in Malaga, Spain, with presence in over 20 countries through office in Spain, Portugal, India, and Latin America. One of our goals is to make building and infrastructure more sustainable, more resilient, and better managed. To that end, we focus on fostering research and innovation activities and on developing digital technologies that transform traditional services into more efficient digitalized ones. Regarding our R&D capabilities, our department is organized around 4 research lines: transport and mobility, energy and buildings, and 2 cross-cutting areas: digitalization and data science, and circularity and sustainability. In EBENTO, we have participated in 2 roles as an end user and facility manager, contributing to the definition of the functional requirement of the one-stop-shop platform, and as technical partner, being responsible for the BIM modeling of several of the project pilots. Specifically, we built the BIM model for 3 pilots: in Spain, a residential building in Valencia; in Greece, a residential dwelling in Athens; and in the United Kingdom, a low-performance dwelling built in Manchester. For each of them, we were responsible for collecting the building information, digitalizing it, and building a BIM model designed to be used within the one-stop-shop platform as the basis for the energy model. In addition, we have participated in the validation and testing of the platform and supported the project's replicability study through the BIM modeling of a replicator, which is a shelter also located in Valencia.
Thank you very much. And last but not least, our project coordinator, Anais.
My name is Ana Isabel Martinez. I'm the coordinator of EBENTO, and I'm here in part of ETRA, that is a technology provider for smart cities. We are working in different aspects of the smart city, like energy, mobility, security, communications, and so on. And we are a company with a high experience, a long experience. We are based in Valencia, Spain. And our role in EBENTO, on one side we are the coordinators, so we are the link between the commission and the rest of partners in EBENTO, ensuring that all things are delivered. In case of any conflict, we can handle the situation and so on. As well, we are technical partners. We have contributed to the definition of the architecture, the development of some tools, the deployment, the technical deliverables, and so on. And we are the integration leaders. And finally, we carry on the dissemination and the exploitation points to ensure that EBENTO is known outside the project.
Thank you all for this presentation. Now let's move to the practical demonstration of the EBENTO One-Stop-Shop. So to start the demonstration, our project coordinator, Anais, will provide a high-level overview of the platform and explain how the different modules are connected to support the stakeholders throughout the renovation processes. Please, Anais, the floor is yours.
Thank you, Raquel. The idea behind EBENTO, as I have commented, and my colleagues as well, is that we have a single platform to access to the different functionalities and the different modules that we have in EBENTO. The idea is that we have a public site in the platform and a private side of the platform. On one side we have the public platform that is the dynamic map. That is a innovative tool that we have developed. The user can go here and check information in his or her city. For instance, they can watch the different information for houses according to the energy performance certificate, and they can navigate around a city. They can go to another city. For instance, this is Tallinn in Estonia, that we have different certificates. So this is the public tool, and so I'm going to. This is as you can see, this is a different. It contains different languages, so you can go to your own data, and after that we can go to the private platform. this is a demo user, okay? So in this case, this is a sorry, this is a demo user in Manchester. So as soon as it loads the certificate, you will see, well, you see the different information. In the private area, you have different modules according to your user profile. Okay, so you have here a support with some information and so on. The idea is that you are not dealing directly with the modules, but you deal with the platform. You have the information of the dynamic map. You have here information about the contrast, that is the EnPC module that I have commented before, the monitoring site, things for providers like supervision of the devices. Okay, for instance, we have an alarm here, some things related to flexibility, that is the demand response module, and the simulation module is here, that is going to be presented later by Nicolas. So as you can see here, we have 5 modules that they as well have different submodules that are calculating, evaluating, doing different things that give information, very valuable information to the end user. So now later we are going to explain the different points in EBENTO. So this is more or less a high-level overview of the platform.
Thank you very much, Anais. Well, this is a great introduction of the EBENTO One-Stop-Shop. So one of the central elements of EBENTO, as we have mentioned, approach, is the energy performance contract. Or while many stakeholders have heard the term, they may not always be familiar with how it works in practice and the benefits it can provide. So now I will go with Shima to explain this, the introduction of the energy performance contracting.
Okay, thank you, Raquel. I will now explain what an energy performance contract is, how we have extended it with innovative models, and how all of this is included in the EBENTO platform. So what exactly is an energy performance contract? At its core, it's a contractual arrangement between an energy service company, which we call ESCO, and a client, typically a building owner or an operator. And the aim is to improve energy efficiency and reduce the energy consumption of a facility or the portfolio of buildings. The key principle here is very simple. The renovation cost is repaid from the savings it generates. If those savings do not materialize, the ESCO bears the risk, not the building owner. The process follows a structured approach. It starts with an energy audit, which is a comprehensive assessment of the current energy use and the potential savings opportunities. And that leads to the project identification, where specific measures and their financial viability are defined. Step 3 is the investment proposal, which is the detailed plan covering a scope, saving projection, and also financial analysis. Step 4 is financing, which can be shared saving, third-party loans, or other mechanism. Step 5 is the implementation by qualified professionals. And Step 6 is the measurement and verification, which include the ongoing monitoring that confirms savings that are actually delivered to the client. And all of this is supported by the formal performance contract, which outlines responsibilities, guarantees, and payment terms between the client and ESCO. I want actually to draw your attention to the reference at the bottom of the slide. This is the European standard for energy performance contracting minimum requirements. It sets the benchmark for technical, financial, and legal aspects of contracts and provide a clear framework for everyone involved, including the policymakers, financial institutions, property valuers, and ESCOs. and EBENTO work is actually fully aligned with this standard. Okay, regarding the innovation in the EnPC models within EBENTO, one of the most important innovations in EBENTO is that we go beyond traditional energy saving. The first extension is what we call EnPC with comfort element. In these models, the ESCO is not only delivering renovation measures or charging for energy consumption, it's responsible for delivering and guaranteeing a specific level of comfort. Customer or client pays a fixed fee covering investment, operation, and maintenance. And in return, the ESCO guarantees the indoor environment meets defined standards. The three most relevant parameters here are temperature, which must stay within contractual limits, humidity with adequate ventilation guarantees, and air quality, specifically CO2 levels. And all of this is fall under what we call indoor environmental quality. The second extension is demand response. This is about balancing the power grid by encouraging the consumer to shift electricity use to the times of higher availability or lower demand. So in this case, a middleman and this can happen through pricing or financial incentives. There are two types, therefore. The first one is implicit demand response, is when consumers react to the price signals, for example, when they are receiving the head market prices, and adapt their behavior through automation or personal choices, including optimizing self-consumption from on-site renewables such as solar panels. The second type is explicit demand response, is when a middleman, that we call it aggregator, group together many electricity users and offer their combined flexibility to the electricity market when the grid needs help. Say there is too much or too little power, and the aggregator send messages to participants to switch things off or on, and everyone get paid for cooperating. So that leads to the innovative business model within EBENTO project. So where ICP, we led the business model development. Our methodology was business model canvas. We adopted specifically for energy performance contracting. In this case, for each main actor among 4 pilots, we systematically map the value propositions, key partners, revenue streams, and cost structures. We assessed and evaluated the current EnPC status of each of our 4 pilots, Valencia, Athens, Tallinn, and Manchester, and defined what kind of a specific demand response and comfort elements that could be introduced into their future energy performance contract. Of course, implementing this innovative model is not without challenges, and it's important to be transparent about them. You can see 6 challenge areas on the screen, and let me highlight the most important one. At the market level, housing fragmentations create high transaction costs, and low energy consumption per dwelling reduces the value propositions for ESCO and homeowners. Also, the traditional markets within construction sector do not promote novel approaches. We also have data privacy and security issue, which is our real concerns, since the consumer data is essential to these models, and it requires a robust and safeguard for data privacy. We also have regulatory framework across different EU member states, and this makes standard services difficult. We also have technical integration of modern smart technology with existing building infrastructure, which make it really as an important barrier. But one of the main and hardest challenges is the consumer trust, and encouraging this consumer to change their behavior when the benefits are not immediately visible is really challenging. Also, there is a significant gap in the workforce and alongside the cultural shift required to move from product-based to service-oriented models in the construction sector. And EBENTO addresses several of these challenges, specifically using this building energy management system and also advanced energy management system to include thermal comfort metric and also visual comfort indicator, and to enable the household to participate meaningfully in this kind of innovative programs. This brings me to what we have done for integration of the EnPC in the EBENTO One-Stop-Shop platform. We have integrated 5 EnPC contract types into One-Stop-Shop. Type 1 is the traditional contract, renovation tracking without saving guarantees used as a baseline. Type 2 is guaranteed energy saving, where the ESCO commits to annual reduction in energy consumption against the contractual baseline. Type 3 adds demand response and flexibility, including smart control and demand response KPIs on top of savings. Type 4 is quality and comfort, including temperature, indoor environmental quality, and comfort KPIs guaranteed. And Type 5 is the full model combining all 3, guaranteed saving, quality and comfort, and demand response simultaneously. One important point, as shown in the notice on the screen, the platform guides user through contract elements and KPIs, but the legal contracts themselves are always signed outside the platform. And platform is only supporting on the decision making and also the managing energy efficiency innovation, and not a legal document generator. To conclude, our EBENTO delivers 3 things. First, flexible EnPC templates adaptable to every project, from basic renovation tracking to full comfort and demand response. Second, we have demonstrated the integrated complexity of combining energy saving, demand response, and comfort in a single contract with minimum savings, maximum payback period, and ongoing measurement and verification, which are all requirements, and it is the ESCO who bears all these obligations to ensure performance is achieved. And finally, the EBENTO platform acts as an enabler into the model of one-stop-shop with clear, accessible contract framework, which give the power to the stakeholder to make informed decision and even create their own energy performance contracting. So that concludes ICP contribution. If you have any question about the EnPC framework or the business model, you can contact me or one of my colleagues. As you can see, the list of the contact on the screen. Yeah, that's it, Raquel. Thank you.
Thank you, Shima. You dive deep into the EnPCs and its challenges and how we implement it into the one-stop-shop. Wonderful. So we have now seen why energy performance contract can be an effective mechanism for reducing risk and facilitating investments. The next question is, how is this process actually supported with the EBENTO platform? So Anais will now walk us through the different stages of an energy performance contract as implemented in the EBENTO One-Stop-Shop.
Okay. Yeah.
Thank you.
Okay, so as Shima has commented, we have different models of contract that we have including in EBENTO platform. And not only that, we have included the different stages that a contract is passing according to the contract, the initial contract that the user signed. So the first point that EBENTO is able to manage is the meeting of providers and customers. Well, this is a service provider user, but in case of a potential customer, they can fill a request of refurbishment. In a similar screen like that, they are going to have a form in which they include the needs, the services that they think that should be done in the house or in the building. So these requests are going to go to the different providers who offer this kind of services. The provider only has to go there and click in the points that they consider they offer, for instance, related to the insulation, doors and windows, and so on. And according to that, they are going to receive here the request. The different requests, they can filter by different activities and so on, and they can see here the different information about the house, the request itself, and so on. When the provider decide that a request is okay for them, they are going to contact to the potential customer. They make some agreements, they sign a real contract, a physical contract, I mean, and then the provider goes to the contracts tab and create a new contract, as you can see here. So they are going to fill different information according to the customer needs. For instance, if they want to track the electricity, the water, the gas, if they want to consider comfort or not, and the engine behind the one-stop shop is going to decide what type of or model of contract is the best for the needs, the specific need of this case. So in different steps, the basic data about the contract, the dwellings or building details, the physical works that are going to be done in the house, a new contract is going to be created. As soon as the contract is created, automatically it passes to the different stage according to the from and to fields that have been filled for each stage. So, for instance, we have different stages like preparation stage, in which the ESCO is configuring all the monitoring things, how it is going to be tracked, the baseline, and so on. Another stage is the refurbishment stage, in which the workers go to the space and repair and replace things. After that, we have the monitoring stage, and finally we have the finalization stage. So, for instance, here you can see a first contract in preparation phase, indicating from that is in this period of time. Here the ESCO is configuring things, for instance, the device the smart meter to track the electricity, the sensors at home, how to load the simulation and baseline. It is going to be reached, for instance, this information, so they can download the baseline from the simulation tool that Nicolas is going to show later. Here they can configure the energy tariff in order to evaluate the cost of your behavior according to your consumption, and so on. Apart from the preparation phase, a contract can be in a refurbishment phase. So workers are going to do to the house, are going to repair the house, to replace things, all according to the contract. And then the builder or the ESCO is going to select, indicating here what actions are being finalized. For instance, replacement of all windows, the painting of different walls at home, and so on. And they indicate the date of this finalization of each subtask. And finally, for instance, you can see a contract in monitoring phase. As you can see here, we don't have data because if you go to the monitoring, if you go to the monitoring, you can see that we have, okay. You have sometimes that the information is not received from the smart meter. So you can see here that we have an alarm about that the device is not sending information. Okay, so in this case, we can know what is happening in real time. If the system detects that something is not working, it's going to send or launch an alarm. It's or if all is working, the indices here are calculating correctly, and so on. So you are seeing here the progress of the contract, and so on. So all stages in a contract, all monitors thing is appear here, and the user, even if they don't have technical knowledge, is able to understand what is happening.
Thank you, Anais. So before starting with the simulation demo and workflow, it's important to understand another essential element in modern renovation projects, so the building information modeling. To explain this modeling and why it plays such as an important role in the building sector, I would like to invite David to explain the BIM and its role in the renovation projects.
Yes, thank you. So what is a BIM model? BIM, or Building Information Modeling, is a digital representation of the physical and functional characteristics of an asset. It is an object-based model that combines a three-dimensional representation of the asset with all its technical and functional information, managed across its whole life cycle. In practice, what BIM allows us to do is digitalize all the information of a building into a single digital environment. We go from having that information spread out across paper drawings, loose digital files, material catalogs, and construction documents, to having it all gathered, structured, and accessible in one shared model. This means that different disciplines can work on a single source of truth, avoiding duplication, inconsistencies, and error. So what kind of information does it contain? In the case of a building, its geometry, for example, the shape and dimension of walls, slabs, roofs, and windows, the site and location, like orientation, terrain, and surroundings, the interior spaces, each one defined with its area, volume, and use, the materials and layers of each construction element with their thickness and thermal properties, and the building system like HVAC, electrical, plumbing, and ventilation. What is it used for? So BIM has many applications in the sector. For example, in design and technical coordination, it allows different disciplines to work together on the same model, detecting clashes before they become problems on site. In construction planning and control, it enables linking the model to the execution phases, making scheduling and progress tracking easier. It is also used to automatically generate drawings and quantities daily from the model. In maintenance and facility management, it serves as a basis for locating building elements and planning their maintenance efficiently. In energy analysis and simulation, it allows us for evaluating the thermal performance of a building before an intervention. And finally, the model acts as a digital inventory of the asset, bringing together all the building information in one single environment. In In EBENTO, the BIM model was developed with a specific goal to serve as the data source for generating the energy model within the one-stop-shop platform. This means we have to model all the information that the energy simulation engine requires. The process was divided into 4 steps. The first was data collection, organized into rounds. In the first round, we gather the geometry and the building envelope, building the 3-dimensional representation and applying to each construction element, its material, thickness, and thermal properties, or directly its U value. In the second round, we collected the internal loads and system, like occupancy pattern, installed lighting and equipment power with their usage schedules, HVAC system, and renewable energy system. So with this information, the BIM model for the project's pilot and replicator building were built. From there, our colleagues from Hypertech were responsible for automatically generating the energy model from the BIM, and finally integrating it into the one-stop-shop platform to be used within the simulation process.
Thank you, David. Well, now we have seen how BIMs enables better data management, collaboration, and decision making through the renovation projects. So now let's jump into the simulation process. A key feature of the platform is its ability to support technical assessment and renovation planning through advanced simulation tools. To demonstrate this process, I would like to hand over to Nicola, who will present the simulation process demonstration. The floor is yours.
Yes, thank you, Raquel. And thank you, David, for this introduction of BIM. This is a very good work that was done by David and Samosa and provided us, as you can see here, with 4 different BIM files of 4 different pilots, namely in Spain, UK, Greece, and Tallinn. So when we are here, you can see the window of the one-stop-shop platform, and here the last part is the simulation tool. When this is launched, this is where someone a user of the tool will see the different projects that they are working on or that they have uploaded already to the platform. For the sake of this demonstration, we have uploaded already the four files of the buildings. So the user typically will select the one that they wish to work on and then click on continue. Here we'll work with the Spanish building. By clicking on continue, this will launch the DSS4N tool. This might take a few moments, depending also on the size of the building, and we'll then launch our tool. This is now how we see the DSS4N tool. It has 2 separate parts. Let's say the one on the left is the model tree, baseline and renovation processes, and here to the right we have the visualization of the building in 3D mode. So let's start with the visualization. So basically this will concern the right part of the screen and the model tree. So the model tree is a drop-down representation of the different elements that are included in the BIM file of the building. So this can include building elements like, if we drop this down, roof, slab, walls, windows, etc. The spaces, the different spaces that the building is divided, or even different devices like space heaters, boilers, IT devices, etc. Here to the right, we can see the building and inspect several aspects. There are options like we can rotate the building, move right, left, up, down, rotate it in this way as well, and then check different aspects. We can select a specific element, like, for example, a window, and then, or a wall. And then if we click, we have other options like these buttons, the search button. We can quickly search for an element that we know the ID or the name of this element. And this, then if we click on this button, we can resume on the initial view, and then we can close these two categories and resume the initial view. So let's check again the model tree. For example, if we want to locate specific aspects of the building, we can hide the building and then show, for example, the slabs, only the slabs. We can then add, for example, the walls. We can also add the windows if we want, or just visualize the windows. Sorry, just visualizing only the windows, etc., etc. So this covers the first part of the tool, of the simulation tool, which is the visualization of our building. Let's check again the whole building. Moving on, we have then the simulation part. First, we have the baseline. The baseline, by baseline, we mean the condition of the building as it is now, prior to the renovation steps. So here, the option is to run simulation to have basic KPI calculation of the building as it is now. This concerns energy KPIs and thermal comfort KPIs. So if we click on the energy KPIs, we'll see here we have several options that can be presented either in annual basis or shown on a monthly basis. For example, we have the annual cooling energy demand, district heating consumption, electric energy consumption, etc., etc. So, for example, here we can check the annual heating energy demand, or maybe the annual primary energy consumption. So if we click outside this box to remove it, then we'll see that these two KPIs are presented here. So the annual heating demand will be roughly 18 kilowatt hours per square meter per year, and the annual primary energy consumption will be roughly 62 kilowatt hours. We also have thermal comfort KPIs that are calculated. These, again, are presented in annual basis or monthly. So the annual, let's see, annual total discomfort time, and then maybe the monthly total discomfort time. And these are presented here below. So I also forgot to mention that we can extend this view in order to have more space to view, to have a better visualization of the KPIs. So the annual total discomfort time is 312 hours per year. And then if this is broken down into an annual basis, you can see how this is presented here for every month of the year. You'll see that in the warmer or colder, usually the colder period, we have more discomfort time, and also a peak here in the summer period in July, most probably because of the hot weather of Valencia. So this is how we calculate the performance of the building before the renovation, and then we can move on to the renovation part. This is the last part of the DSS4M tool. So here we have the measure selection option, where we have different measures that can be applied to our building. We have categorized them in passive, active, and renewable renovation measures. And each category has a subset of renovation measures. For example, in passive, we can have roof insulation, facade insulation, and opening, meaning opening the windows, a replacement of windows. So if, for example, we want to add insulation and check how the building will perform with the insulation, we can add some insulation to the external facade. So here we have several options. Let's choose, for example, EPS of thickness 100 millimeters. And then let's also add something. Let's replace the windows. So here we have double glazing and triple glazing. Let's select here replacement of the windows and adding double glazing with aluminum frame. So here now we have selected two renovation measures, and then we can run our simulation. When this is completed, when the simulations are completed, we'll see that we switched to the scenario results tab. And here we have the different renovation scenarios. So now we have 3 renovation scenarios here. Why? Because we have one calculated for each renovation measure plus one for the combination. So let's check the first one. If we click here, we'll see that the renovation scenario includes the external insulation and also the double glazing. If we click on the next one, we'll see that this is one of the measures on its own. So this is the external insulation, and the last one should be the replacement of the window. So then what we can do is that we can compare the performance of the baseline scenario and of the renovation scenario. So when we select the baseline with the renovation, we get a drop-down menu with the KPIs. So here, for example, we can choose again on annual and monthly basis. Let's check the annual heating energy demand to see how the renovation influenced this. And also, let's check comfort KPI. So let's check the annual % time uncomfortable. Clicking outside to close the window, we will see that we have here the 2 KPIs presented. So for the annual heating energy demand, we see that the baseline has dropped. The heating energy demand has dropped from 17.8 to 12.3 kilowatt hours per square meter per year. And the discomfort, the percentage time of uncomfortable has dropped from 15% to 9.7% per year. So summarizing this, the DSS4N tool has 3 options. The one is to visualize in building, see how our building is, inspect some elements of it, inspect categories, specific categories that we want to see, then have a performance, the baseline performance calculated, and then add specific scenarios that we want to check their performance and compare them to the baseline scenario and see what effects this will bring to the performance of the building. This information is then provided to the common data environment of the one-stop-shop platform and is made available to the other tools of the project in order to be incorporated into the energy performance contracts, as were shown previously, as explained by Shima and shown by Anais in the previous demonstration. I think this is it for the simulation tool, for the demonstration of the simulation tool. Raquel, the floor is back to you.
Thank you very much. Very impressive, all your work within the EBENTO One-Stop-Shop platform. Congratulations.
Thank you, Raquel.
So we have now followed the renovation workflow from initial inputs through a scenario analysis and decision support. However, renovation journey does not end when measures are implemented. Monitoring and verifications are essential to ensure that expected savings and performance targets are achieved. Anais will now present the monitoring stage within the EBENTO platform.
Yeah, thank you, Raquel. Okay, well, as Nicolas has commented, based on the simulation or the different simulation about the space that the service provider does, the analysis is going to be different. So as I saw it before, in the type of contract, the service provider is going to upload the baseline, and based on that and the type of contract and so on, we are going to evaluate different things. So in the EBENTO One-Stop-Shop platform, we have a tab, the energy and comfort, in which the user, customer and service provider are going to visualize the situation, the physical situation of things evaluated at home. So this is the same user as I showed before. In this case, this provider only has a contract in a state of monitoring, and then only this is possible to select. But in case of the service provider has different contracts in monitoring states, they are going to visualize here a list of contracts. Okay, so the first point of the monitoring page is that here the user can see what contract corresponds to this house, the situation of the house in the city, what is being monitored, and if any sensor is installed, if one controllable device is included, and so on. Here we can see the different information regarding the cadastral register is according to the house. So, depending on the type of the legislation of each country, the user is going to visualize different information. Of course, for all countries we have the same labels here, but depending on the country, the possibilities are different. For instance, this is a case of a contract in the United Kingdom, so they have the potential certificate that the house can reach. If the user clicks here, they can see different extra information about the house. For instance, now you are in C level, you can go to B level. This is your average energy consumption, and this is your CO2 emissions corresponding to that consumption. This is official information from the cadastre. After that, we have the evaluation of the situation, the indices, for instance, the electricity consumption and the CO2 emissions that corresponding to the KPIs or the indexes signed in the contract. As I have commented before, this is a case that a device the smart meters is not sending information, so this information is frozen. It is to zero. But if we have a house with all working, these indexes are going to be calculated. After that, below that, we have all the smart meters that we are controlling. In this case, this house only have a smart meter for the electricity, but if you remember my explanation about contract, we can monitorize as well water and gas. So if you have another smart meter for gas or for water, you can register and you will see the information here. This is a dynamic chart, so you can go to the site that you want and you see what is happening at home. You can change the period of time to visualize, you can download the data, and in case that you don't have a smart meter, you have the possibility to upload information to the platform. So for those houses that have an old counter or meter of electricity, gas, and water, they can send information, and the platform is able to make calculation in the same way as if the information is directly sending information. And after that, we have before that, we have a section in which the user can have an estimation of what appliances are using in each moment. We are using a backend process of NIL, that means not loading monitoring, non-intrusive load monitoring. That means that the energy consumption is going to be analyzed, and with artificial intelligence, the tool is able to know which appliance is used in each moment. The situation is that in this house we have a gap here of metrics, so this evaluator is not going to calculate anything in this house, but in case of a user, a house is with all connected, this card is going to show the information. So the user can say what type of appliances he or she has at home, and this analysis is going to be better than if you don't set anything else. And as I commented before, here you have the different status and alarms corresponding to the smart meters. For instance, you can see that we have the gap, and here we have the alarm corresponding to that. In case that the user has contracted comfort improvement, we are going to have another section here with that information. So I'm going to show you an example. For instance, this is the case that the user has contracted the comfort evaluation and improvement. So they are going to receive information about that. For instance, the thermal comfort, the old algorithm has evaluated that is uncomfortable. Why? Because the temperature can be high to the type of inhabitants in the space. For instance, 24 degrees and humidity, relative humidity of 59. If you want to see another point is the air quality. If we have a sensor of CO or other gases, the module can evaluate this according to the model of EnPC that Shima has explained before. So we can see here the metrics that are being registered, the relative humidity, the temperature, the outdoor temperature, the CO2 levels, and here the settings are the settings that the user have include. For instance, that they don't have a air conditioner, they only can open and close the window to regulate the temperature. They don't have any baby or any elder people at home, and the activity in the space is more or less to be relaxed at home. See, if in case that, for instance, you want to monitorize a kitchen, you can set that activity is cooking, and the evaluation is going to be different, because according to your activity, the comfort level or the comfort feeling is totally different. So more or less, this is what the user is going to visualize in the platform. As you can see, according to metering and according to your configuration, you are going to receive different things here. And that's all from monitoring stage.
We have seen all the process and demonstration of how EBENTO One-Stop-Shop works, and also how we implement the energy performance contract. So to conclude, I would like to ask each partner to share one final message. In one sentence, what is the main benefit of the EBENTO One-Stop-Shop, and what makes it different from existing renovation solutions? So maybe Nicola, can you start?
Yeah, sure. Thank you also, Raquel, for organizing this with Anais. It's good to finalize the project and demonstrate all aspects and tools that were developed. So in one sentence, I think that the innovative tools that we have developed during the project help to the transition and the transformation of buildings from static structures into data-driven systems that support informed renovation decisions and enhance energy performance, and also can, of course, lead to reducing bills, heating bills, electricity bills, etc.
I will say that for us, platforms like the one developed in EBENTO demonstrate how this digitalization can make building renovation processes more efficient and user-centric, streamlining what is typically a long and tedious process for all parties involved.
Okay, thank you. Shima, please.
So from our perspective, EBENTO makes building renovation simpler for all the stakeholders. We have one platform, one contract, and also guaranteed results.
Great. Powerful. And Anais?
Well, in my opinion, EBENTO has a social aspect, that is that it can help combat energy poverty thanks to the energy performance contract. If a person cannot pay for a complete renovation, he or she can access to this kind of contract that allows to pay the same in each month, so they can access to the complete renovation easily.
Thank you all for these valuable insights. So today's webinar has shown that how EBENTO One-Stop-Shop supports the entire renovation journey through a single integrated platform, helping stakeholders make informed decisions and facilitating the implementation of the energy performance contract schemes. You may ask, what's next for the EBENTO One-Stop-Shop? Well, we are working in including more cities and countries because each country needs a previous study due its legislation and particularities. In addition, new projects based on EBENTO are coming, so stay tuned. And also we expected that EBENTO will be the basis for new work, including new models of energy performance contracts and being operated with external tools. Although the project is coming to an end, its results are and resources will remain available. So we encourage you to visit the EBENTO website and explore the project outputs available also on Zenodo, such as deliverables, papers, and other documents, and watch additional materials on our YouTube channel. So you will find more videos regarding the one-stop-shop demonstration and the modules that we have introduced today. So if you would like to learn more about the platform or get in touch with the consortium, please don't hesitate to contact us through the project channels. And on behalf of the entire EBENTO consortium, thank you all the speakers and participants for joining us today.
Thank you as well.
Thank you very much for your big effort.
Thank you, Raquel.
It was a pleasure to work with you. So stay tuned.